Hi, everybody, and welcome to my talk. It's really nice to see so many people here interested in, EF and performance. So thank you. It's really cool to see all of you. So I'm going to be talking about officially about update performance improvements in EF Core 7. So we're going to be diving under the hood of how EF Core 7 actually does, how the sausage is made, so to speak. But the idea here is also to take some lessons from it about general optimization and what we should be paying attention to when doing performance. So performance is very tricky. So I want to show people what goes on under the hood, but also concentrate on what this might mean for you. So there's going to be a lot. I'm going to at least try to make a lot of lessons, like general lessons here. And we're going to do a few slides, but this is going to be almost completely within the code, which is as a good presentation should be. So let's get started quickly. So a few words on who I am, just so that you know. My name is Shai Rojansky. I'm an engineer on the data access team at Microsoft. So that means I work on EF Core every day. That's one of my projects there. The team takes care of anything else kind of related to data access on the client side. That means I also work on database drivers on ADO.NET, which is the SQL API in .NET for database drivers. This is the abstraction for all database drivers and basically anything related to data access in .NET. In addition, that's in another universe, let's say, I also am a lead dev kind of on NPG SQL, which is the Postgres driver for .NET, and also the EF Core provider for Postgres, which is built on top of it. So basically, if you're using Postgres via .NET, chances are you're passing through stuff that I work on also almost every day. Postgres is very dear to my heart. Connected to another point here, I'm a Linux guy. I came from that world like a long time ago. I used to be very anti-Microsoft, and somehow I find myself working for this company of all companies, but it's better now, so it's all fine. I have a particular focus on performance in general, both within the team and in general. So I'm very passionate about perf, and I worked a lot on perf both in EF and at the NPG SQL level. So it's something that I care about a lot, and perf is very cool, very fun, and also if you understand, understanding your application's performance means understanding your application in a very, very significant and deep way. So anyway, you'll see what I mean, I think. And I'm based in Berlin, so not too far away from here. A few words for those of you who don't know. How many people here know about the Tech Empower benchmarks? Just sort of, okay. A decent amount, okay. So the Tech Empower benchmarks is a set of independent benchmarks focused more on web stacks. So basically, it's standardized scenarios where you have a web server and you bombard it with requests, and it does some database requests, some basic, very basic scenarios that have become kind of an industry standard. Lots of languages and platforms have submitted their applications into it, and they do a round every year. So, and this is the sort of leaderboard for the Fortunes benchmark. It's a good way to compare different languages, but it's also a great way to get yourself motivated to work on performance, right? In the latest one, this is the round that just finished last month. .NET, very important. With ASP.NET, without EF Core, is here in place 16. Last year, we were actually in 9th place. There's many shifts, many changes here. This is Ubuntu 22, where there's kernel changes for various speculative execution mitigations. Doesn't really matter. It moves around a lot. I will say that a lot of these frameworks you'll see at the top, some of them are sort of experimental ones, not necessarily production ones. Others, if you want to use C to write your next web application, you're very much welcome to do so. I would not necessarily want to be in your shoes, but you can choose. Some of these are going to be, I'm not trying to say that those on top of ASP.NET are bad in any way. There's some very good Rust and Go and various things, but ASP.NET is up there among the best, let's say, which is an important thing. We use this inside the .NET organization. We track this very, very closely as a way of ensuring we don't do any regressions. That's very important. We don't want to regress performance accidentally without unintentionally. And we also use this as a motivational tool to kind of, let's push the bar even further. So this is a central tool in this thing. I will just say, In EF Core 6, this is 2 years ago, we did a major push inside EF Core to make the query pipeline faster. And this means here I'm concentrating on what I will call runtime overhead. This is the classical kind of optimization exercise. It means you profile your application, you see where EF Core itself is adding overhead to requests, like there's too many allocations here, this function is too heavy, and you make it run faster. But this is really about runtime performance, application performance. It doesn't cover, for example, the quality of SQL, which EF Core generates. That's a completely different kind of performance improvement, and in fact, usually much more important, and that's one of my messages to you in this talk. So if you have a super low overhead ORM, like zero allocations, it's all super cool, but the SQL it generates is bad, that's really stupid. What you want, you don't really care about some extra allocations. What you really want, first of all, is to have good SQL and so on, and that's really one of the core messages here. So we did a lot of improvements here in terms of runtime. This is the first, let's say, less important kind. We did a lot of runtime optimizations here. We used Dapr. Dapr is a micro ORM. It's an alternative to EF, which is much more lightweight. And we use it as a sort of, let's see how close we can get to Dapr, right? The idea was not to beat it or become better, but again, use it as a motivational tool that really helps with performance investigation sometimes. And we got to within about 5%. In this benchmark, we actually even got a little higher, but I mean, we're not higher. We're not really, EF is not really faster, but it is somewhere in the ballpark. So what I'm trying to say is, you shouldn't, there is this preconception that all ORMs are slow, and that EF specifically is big, it's a big beast, it's gonna add a lot of overhead. That's not completely incorrect, okay? I understand where this comes, and it is a little bit true, but you should always examine your prejudices, and we've done a lot of work. EF does a huge amount of magic to make sure that it runs really quickly. So it shouldn't, runtime performance and overhead shouldn't really be a big deciding factor in your decision to not use EF Core, in my opinion. It is worth mentioning, for this kind of thing, we use various high-performance techniques in EF. So if you just use generic, naive tutorial code for EF, yes, it's going to be much slower than Dapr. For example, tracking queries are going to be slow because you track. Dapr doesn't track, so there is no overhead there. So, of course, it's not really an apples-to-apples comparison. So you have to do certain tricks in performance to make EF work as fast as Dapr or anything else. But it is possible if you're in that space and you know that it's important. Let's move on. Again, I want to get to the code. If you are in this kind of space where you're high performance and you want to look into EF Core, I highly recommend looking at our documentation where there's exactly the kind of tips for creating an EF Core application in a way that's going to be very performant. You're going to use DB context pooling. You're going to use possibly compiled queries. There's various things that you're going to do to code a bit differently so that things work super fast. But I do not recommend this. The normal application should not be doing this. This is allocating your attention to the wrong thing. In general, it's unlikely to matter for your normal line of business application. That's an important message. Okay. What about updates, though? So again, in 6, we did a lot of query optimizations. Again, they were very much runtime, so classical performance optimization, which is the kind of stuff you see on Tech Empower. But in EF Core 7, we kind of shifted gears, and we went into the update pipeline, which is also important. And there, I definitely did not concentrate on runtime perf. As I said before, what's much more important is how EF Core actually communicates to the database, what kind of SQL it does. So with this, we're done with the slides. I'm very happy. We can now move to the interesting part. Whoops, sorry for this silly kind of transition here, but I didn't prepare it well enough before. So let's try to see if I can get into presentation mode. No? Okay, yeah. Can you see this? Or is it? It's a bit too small. Huh. Oh, I'm sorry. I should have probably done this a bit better. There we go. This is what I'm looking for. We're going to get there. I promise. I thought this would work better. There we are. This should be much better now, right? Okay. Okay, that's actually going to be a bit of a problem. Oh, 1 second. Sorry, this is something I should have tested better before. Can we see the screen somehow? Is it? I'm sorry about the technical difficulties. We'll resolve this very quickly. We don't need to go back and forth, though. We're just going to stay here. No? I'm going to have you all come up here and look at my little screen at the end. I apologize. We should have done this before. This is my fault. There we go. Okay, we can move on. Thank you very much. Thanks for the technical support there. It's all my fault. Okay, so now we're in code, and we're going to start going through this. So I have a very, very simple application here, EF Core. Anybody who used EF Core knows what is going on here. So we have a context. We're adding a single instance of a blog, super basic stuff. Then we're using save changes to save it to the database. I've got a classical DB context working against SQL Server, right? I have done one thing which is maybe slightly interesting. I've added logging events for transaction committed, transaction started, and command executed. We want to look at the logs and see these events as they happen. Down below, I have a super simple classical model. There's a blog with a name and a rating, and there's a one-to-many relationship to a post, okay? Super, super basic. If you look at what's going on here, I actually have the same program CS referenced in a project for using EF Core 6, not the old EF6 pre-EF Core. We're EF Core 6 2 years ago, and EF8, and we're going to compare the kind of SQL and output that we see from both of them. So let's run this with EF6 for once, and we'll see what comes out. There we go. My computer is a little bit slow. Okay, so let's start taking a look at this. So the part that everybody expects, and of course is here, is this insertion, right? So we insert into blogs, name, rating, super simple, super trivial. But we also have this select ID from blogs where blah, 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 some SQL Server thing. So what's happening here? It's pretty simple, right? But I'll go through it. When you have an ID, an int, right, on the blog, then by convention, EF Core makes that a database-generated ID, or what's known in SQL Server as an identity column, right? So the ID numbers are going to be incrementing in the database. SQL Server manages that thing, and what we want with EF is to get those IDs back from the database after the insertion. That's important because maybe now in your web service, you want to communicate that to the client over the web in JSON or something like this. So EF Core always ensures when you insert that you have any database-generated stuff. Also in updates, by the way. So it has this job of having to get back all the database-generated stuff. So what you see here is a pattern that I'm going to call insert plus select, right? So in order to get that database-generated piece of information, I insert, and then I select out the database-generated part of what I just inserted, right? So this is the first thing. That's how EF Core did it up to very recently. But there's another thing I want you guys to understand, and this thing that we have here, this logging event, shows that we're starting a transaction before and we're committing it afterwards. Trivial, right? Of course, EF Core, we're in databases. We have to guarantee the atomic operation of save changes. If we didn't do that, and you have a save changes with many things, it aborts in the middle because whatever, something happens, and you have half an update app happening and not the whole thing. So this is all very basic stuff. So what we'll do now is we'll run the exact same code with EF Core 8, and we'll see what happens with that. There we go. So most of these optimizations actually happen for EF Core 7, but EF8 is the first time that it's in an LTS version, and I also think that not enough people are aware of what I'm about to show you, so I think it's really worth your time. So the first thing you'll notice is that there's no more insert plus select. EF Core 8 or 7 does something else. It does insert, and it uses this output clause. This is something that EF did not do before, to do it in one SQL, right? So insert in all databases, Postgres, SQL Server, all databases have some sort of support for inserting or updating or or deleting and then retrieving some column from what you just inserted. So we took 2 commands, or 2 statements to be precise, and reduced them to 1, which is pretty cool, right? Like, this is better. But I have to admit, if you now looked at, you did some profiling, benchmarking of this will not be like a huge perf win for you. Like, just going from insert plus select to this, not a super big deal. The really important thing here, what I really want you guys to see, is that around this command, where we have all this, we no longer have a transaction. We did not start a transaction before and commit it afterwards. So what's happening here? Did EF Core suddenly decide to not be transactional anymore, to not guarantee atomic, operations? The answer is, of course, no. So it turns out, in databases in general, a single SQL statement in general is always going to be atomic already. You don't need to start an explicit transaction because a single command or statement is already transactional. Think about it for a second. If this weren't the case and you're doing an update that touches, 5 rows in your database, and update were not atomic as a single thing, then everything would be chaos, right? The world would break down because you update 2 things, database crashes, and your database is now in an inconsistent state, right? So databases guarantee that a single SQL command will be atomic. And we can take advantage of this. So this optimization is a very simple one. Basically, EF Core detects when it's going to send just 1 single update, and it's going to avoid wrapping it in an explicit transaction because it already has an implicit one, right? So we're not achieving anything by doing the transaction. Now, why is that such a big deal? Why am I talking to you about this? So it turns out, I'm going to step away because I'm going to do a rant. So it turns out that when you do a transaction, when you begin a transaction, that's a round trip. That's a word you're going to hear a lot during this talk. You go to the database and you say, please start a transaction. The database comes back and says, sure, you're good to go. Then we do the actual inserting and stuff, comes back. And then we have to do yet another round trip just to tell the database to commit. So for one operation, we just did 3 round trips. That is the main point behind this optimization, right? So first of all, what I'm trying to say is this thing where we collapsed insert and select into a single insert is more interesting because it makes it into 1 SQL statement, and that allows us to take advantage of the atomicity of single statements, right? That's the cool part. It's not so much making it into 1, it's that it allows us to get rid of the explicit transaction and therefore of 2 extra network round trips. Now, and this is the part where I hope everybody kind of really gets the point. This has nothing to do with databases now. Round trips are one of the most important things to take care of, to understand, okay? We come from a world, if you look like a long time ago, typically you had on-premise before the age of the cloud, you had your application server in the rack, and right next to it in the rack, you had the database server. They had very low latency networking. So latency was not a big deal, it was very low, and therefore if you did another round trip to the database, that's not a big deal, because latency was low. Same thing, I just ran this demo on my laptop, right? It's all running here. There's no latency. It doesn't matter if I contact my database 3 times. Not really, just a tiny bit. But in the real world, and especially since we now have the cloud and cloud databases and things are getting farther apart, latency is growing. And applications which are so-called chatty, they chat a lot, they do a lot of back and forth, really suffer from the performance. If you do performance, there's a chart somewhere on the internet. I should have brought this with a presentation. You need to know about orders of magnitude. So if you access a register, that's super fast. If you access memory, RAM, compared to the register, that's an order of magnitude more. But it's still pretty fast, right? But if you access the hard drive on your machine, that's yet another, that's horrible. Hard drives are super, if it's a SSD, it's kind of fine. If it's a spinning disk, dear God, those don't really exist anymore. But, you have to be aware of the orders of magnitude. If you now leave the computer, no, you're not accessing an SSD, you're going to the network. And it's an actual, the database server is somewhere far away. Dear God, this is going to be measured in milliseconds, right? So any additional round trip is going to add possibly milliseconds as your database comes away. So I sometimes see this. This is super funny for me. I talk to people or I see issues on GitHub, and the guy is hunting down allocations in .NET because it's cool, right, to hunt down allocations. And I do that too. I love to do it because it's cool. But then you do this runtime optimization thing, and you fail to take into account extra round trips you're really doing it wrong. You're concentrating on the wrong thing, right? So always be aware what it is that what actually matters in your application. And by the way, the worst thing is if you just naively profile an application, extra round trips don't exactly show up there in an immediate way, right? It's very easy in a profiler to see this function is long. Yeah, I mean, I'm spending all my time in this function. Round trips can be a bit tricky, especially with asynchronous I/O. You don't really see, it's not the function. We just happen to wait on I/O there. It kind of can get lost very easily if you're looking at the wrong things in your profiler. So that's my rant, very important. In general, regardless of databases, always be thinking about when you're doing extra round trips between components of your, of your system. Doesn't matter if it's a database, you have microservices that have to talk between them. Round trips, round trips, round trips. Very, very important. Okay. So, so that was my rant about round trips, right? So we did this transaction elimination, I call it, optimization. Of course, if you're doing 2 inserts, or we'll see better. If you're doing like multiple things, EF Core needs to do a transaction to guarantee the atomicity, right? So this optimization only kicks in if you're doing a single thing. But that is the majority of cases. Like in most cases, people actually insert a single row, or they delete a single row, or they update a single row. So this optimization is actually extremely valuable, it turns out. Okay, let's move on. I want to show you guys another really, really cool optimization that we do. So I'm going to go back to EF6, EF Core 6 once again. And instead of just inserting a single thing, what I'm going to do is I'm going to insert 4. So I'm going to do a quick for loop here. I'm doing live coding, the worst thing you could possibly do in live coding and so on. So I'm going to put this inside. I'm going to even add so that we get the names. So now we're inserting 4 blogs instead of just 1. Easy peasy, right? I'm going to run this. Now, we all expect to see something like maybe 4 inserts, batched in a single round trip, I hope, right? Because it is EF Core, it does batch things. Maybe if you know your SQL, we can also do it in a single insert with 4, values, right? So which one are we going to see? I'm going to leave you in suspense. So obviously, we're not going to see either. We're going to see something very complex and ugly, which I think few people here understand. So how many people here have used merge? Okay, quite a lot. Okay, interesting. So I wonder what you'll think of, our usage of merge here, by the way. I'm kind of interested. So what this does is the following. I'm going to walk you through this line by line, but we're not going to spend too much time. If you don't get it, it's fine. It's a bit complicated. It's not fundamental to understanding this talk. But what EF Core here does, the first thing is this declare. We declare a temporary table, okay? So we've prepared a temporary table. Then we use merge. Merge, very simple. The idea of merge is to merge one table, data from one table, into another table. It is the most misused statement command in history in general. People use it for all kinds of things which it was not meant for, like upserting and various things. It is not meant for this. It is meant for merging data from one table to the other. So what does this have to do with this? We're just inserting 4 rows from the client, right? So why merge? What we do is pretty simple. What we merge is we use SQL values to create what's called an inline table or result set from parameters that we send out. So here we basically construct a sort of table from the parameters that we send. And these parameters, if you look a little bit up, these P0, P1, P2, that's the names of the blogs that we're inserting and their rating. So the data, basically, we send it as parameters, and then we use values to turn that into a table. And that table, we merge into the blogs table. Okay, that's basically a sort of a hack or technique for doing this insert with one statement, and it's going to actually be faster than if you did it another way. So it's important to say, if you just did a single insert here with 4 values, it would be faster than this merge. But EF Core has to get back the IDs that were generated in the database. That's very, very important. And if you do a single insert with 4 values of rows, you get back 4 IDs, but there's no guarantee on the ordering of those IDs. So you have no way of matching back those IDs to the blog instances which they represent. And we have to do that in EF Core. That's a challenge. That's our contract with you guys, the users. And when you have this constraint of having to get back the IDs and populate them back into the correct blogs, then this is the fastest way to do it. Basically, you can take my word for it, or I'd love for you to test it and tell me I'm wrong. I'm always interested in this. But this is we call this a sort of a bulk insert kind of optimization. It's not the bulk copy that you can do in SQL Server. It has nothing to do with it, but it is a sort of a nice optimization. Moving on, so we merge this table that we've created out of parameters into blocks. And then we do something kind of interesting. We do output the inserted IDs as well as there's a position hack into the temporary table which we created here. Remember the temporary table? So we place those auto-generated, database-generated IDs into that table that we prepared in advance. And then we select those IDs from that table. It's sort of a little bit similar to what we saw before. It's a sort of insert plus select. So here it's merge plus select. But it's the same concept, right? OK. Let's do the same thing now on EF Core 8 and see what happens. As you can expect, something is going to be a bit different. So we're still doing merge, right? It's the same idea. We're still sending those parameters, merging them into the target table, which is blogs. However, we no longer have a temporary table. There's no more declare that you saw before. And down here, we don't have output into inserted, which was the SQL from before. Instead, we just have output like this. And that goes directly back to the client, to us. So that streams those IDs back to the client. There's a whole hack here with the position. It's pretty complicated, but I just don't have time to go into it. So we've removed that temporary table. Now, why am I talking to you about the temporary table? So it turns out temporary tables in SQL Server, and not just in SQL Server, are very heavy. There's a massive perf problem with doing what we were doing before EF Core 8. I don't know if people here if anybody here is deep enough into this kind of thing to know what I'm talking about. It's such a massive thing that I'm actually going to run a live benchmark, which you should never do in a conference, but I'm going to do it anyway because I feel like it. So let's see. Oops. Right. So I have my command line here, and I've set up, before we go into the command line, I've set up a benchmark here. Like this is a, come on. OK, there's a benchmark.net application. I hope this is all going to work. There's a small benchmark.net benchmark that basically does the exact same thing, insert 4 rows, right? You trust me. I'm not cheating. This is the real thing, what I'm actually saying. And I have this reference from 2 projects, from 2 projects just like before. So I'm going to run this under EF Core 6, and we're going to see what happens. As this starts up, and I mean, hopefully this actually runs. Not EF6, sorry. What I meant to go into is benchmark EF6, which is the benchmark application, obviously. As this starts up, who here has used benchmark.net? I'm very happy to hear it. If you are going to, so everybody should benchmark, obviously. You should always benchmark in order to do, rather than theorize or ask questions, just check it, right? And when you benchmark, always use benchmark.net. It's taking care of stuff like warm-up here, right? You have no idea how often we get issues in EF Core where somebody says, EF Core is slow, here's my benchmark, and you look at the benchmark. There's no warm-up. I mean, so of course it's going to be skewed. It's wrong in many, many ways, right? Benchmark.net just takes care of this. So this will take a long time. It actually changes a lot. There's a lot of variance, which is why there's going to be a lot of iterations here. But in this particular instance, it took, interesting, before when I ran it, it took like 1.8 milliseconds. Now it's 1.6 milliseconds. So this is to insert 4 rows into localhost SQL Server, which is suspiciously slow, right? Like, why is it taking so long? 1.6 milliseconds. So let's go and do the same thing in this one. Every time I run this, it comes out different because SQL Server also is a little bit, let's say, unstable in terms of like very stable throughput kind of performance. So I'm going to run this from EF Core 8. OK, and already we see some sort of difference, 400 microseconds. So that's a 4-fold decrease in, or increase, depending how you see it, in throughput, right? Just cutting out that temporary table, that's a pretty massive performance optimization. Now, it's not just that thing. I'm gonna quit this because I think you already get the point, right? We don't need to run this to the end. The nice point about this, what I really like about it, is that we didn't just get rid of the temporary table. Because we also collapsed everything into a single merge, right? Remember, we have a single merge. What happens? No transaction, exactly. I love this because it's two optimizations working together. That's the nice thing. Merge is also going to be okay here. We don't need to wrap it in an explicit transaction. Therefore, we also got rid of those 2 round trips. That's not really effective here on this laptop because I'm running against localhost. But in the real world, that's going to be very effective. So you've got optimization on top of optimization, basically, which I find very cool in general. At this point, you're probably asking in your head, why was this done only in EF Core 8? Like, are these EF engineers stupid? Like, what is the story here? Why this temporary table craziness and not this thing? I'm definitely not that smart that I discovered this and nobody thought about it before. So there's a nice story here. It turns out in SQL Server, the output clause that you have seen to output stuff to the client, SQL Server is a very finicky database. I'm a Postgres guy, by the way, but anyway, that's neither here nor there. I'm not going to say my real opinions here. I'll just say SQL Server is a little bit finicky, and this output clause that you see me using here is incompatible with various things, specifically the most prominent one. If your table happens to have a trigger on it, then this will not work. So you use the output clause, it will say, nope, sorry, I can't do it. There's a trigger on the table. When EF Core was originally developed a long time ago, the idea was this should run anywhere and always. That was kind of the point. So we prioritized compatibility over performance. We also, I think nobody benchmarked and knew how much temporary tables were heavy for use, right? Fine. So we did this. Now, when we discovered that there's such a massive perf difference, 4x perf difference just because of that thing, we had a discussion. So what do we do now? One option was to say, break the world. Like, we're going to just switch to the new thing. If you happen to have a trigger, your application is now broken. And we're going to give you an opt-out. So we're going to give you a way to tell us, this table has a trigger. Please don't do the optimized thing because it's not going to work. And the other position is to say, no, we have to maintain backwards compatibility and maximum compatibility as well. So we're going to make this an opt-in. So EF Core would be slow by default. But if you want to go high perf, you go and you opt into this kind of thing, and then it's your responsibility. That was actually not a trivial discussion to have. As you probably know, Microsoft really prioritizes backwards compatibility. But I won. I'm super happy about it. So, of course, I didn't win. We had a discussion. And given the fact that it's such a big performance difference, and people's usage of triggers, not everybody uses triggers, right? We did decide in the end that it's wrong to penalize the default performance for unsuspecting users who just use EF Core in a normal way. It's wrong to penalize it for everybody for that minority of people that happen to use triggers. Also, perf, the problem with perf, it's not like it doesn't work. It works, it's just slow. It's far better to have an error and then we actually built a super specific informative exception to tell you, hey, you have a trigger, so you have to use this API to opt out. We're basically telling you in the exception exactly what you need to do, which is the ideal thing. Whereas the opposite with perf, nobody would know that they have a problem with perf unless they started benchmarking it. This is why I think that in general, things should be designed in that sense, a little bit perf first. This is not about correctness. Of course, things should be first correct, but then they should also be performant. And if they're incompatible with a certain segment of your users, as long as you can make that very discoverable and clear and allow them to transition to the correct opt-out, that is the ideal situation, in my opinion, and that's what we did in EF Core. And it's not uncontroversial. Not everybody necessarily agrees. There are people that think backwards compatibility is king, but here I am happy, personally, I'm happy that we made this decision, and that means that EF Core is faster for everybody, all out of the box, and I think that's the correct thing. Okay, I hope that all was clear. I do want to show one more optimization. I think I have time. Before I switch to the last part of the talk, I still have like a few things to show. So what I'm going to do now, we're going to switch back from the benchmarks to the code. I'm going to actually keep this here as a comment. Let's go back to a single block. We don't want the 4. But what we want is to have some posts, right? I have this one-to-many thing. So let's do a list of posts and do exactly one post in here with a title of foo, right? All very, very simple and clear. Let's run this with EF Core 6. we're going back to the whole database-generated stuff that I already started. So we're EF Core 6. So what you see here is you have one insert into blogs, and then you have another insert into posts. When you read the logs, it's important to understand that this is a DB command. It took 22 milliseconds, and that is a DB command that took 2 milliseconds. So these are 2 round trips, one for blogs, one for posts. In this case, it's actually justified. There's no other way, because blogs has a database-generated ID, and posts has a foreign key that needs to point to that blog. So the only thing we can do here is to insert to the blogs table, get the ID back, and only then can we insert a post, right? There's a dependency between these 2 inserts. This is the point that I'm trying to make. So EF Core has no choice. If you run this with EF Core 8, there's no optimization that's going to make that go away. There's a dependency between the 2, so separate round trips. But now I'm going to do a slight change here, and I'm going to do, instead of ints, I'm going to switch it to GUIDs. What is he doing? Where is this leading us? So I'm going to run this with EF6. This is my way also of making sure you're aware of this difference between GUID and int behavior. So very different. We only have insert. We don't have insert plus select anymore. We're not selecting back the thing. In fact, we're inserting the ID into the database, right? And you can see the GUID here. So this is because EF by default, it's by convention behavior here, for GUIDs is to generate a GUID client-side, because it can. With identity columns, you can't. The database is the only one who can actually generate those IDs. With GUIDs, we actually can do it. And we even kind of duplicated the algorithm for sequential GUIDs, if people are aware of this kind of thing. The SQL Server sequential GUID thing, we duplicated in EF Core, and we do it client-side, because there are some advantages to it. So now you're looking at this log, and you're seeing there's no more dependency between the principal insertion and the dependent insertion, right? There's no more problem. We can insert both of them in a single round trip, and yet we are not doing that, right? You're still seeing 2 commands, one insert and another insert. So now this one, if you run on EF Core 8, will look finally a bit different, a bit better. You can see the 2 inserts happening in a single round trip now. So we removed 1 round trip. Before it was 4, begin transaction, insert blog, insert post, commit. Now it's only 3. We still have to do the transaction because it's 2 separate inserts into 2 separate tables, has to be atomic, and so on. So those of you who are starting to think, wait, but that means that GUIDs are super cool and I must switch my database to use GUIDs everywhere, don't do that. I mean, it's a big discussion, GUIDs versus IDs. I'm not getting into it, but I will say this. EF does have, I'm going to switch back to ints, EF does have a feature which I think nobody here knows. Okay, who knows what HILO is? Okay, much more than I thought, honestly. Have you actually used HILO with EF Core? Not you. I don't care about you. Okay, good. So I'm just going to show, I'm going to do this thing just so that you guys are aware of it. Yeah, I still have a bit of time. I can have fun with this stuff. So I'm going to go to the ID, we have the blog, and I'm going to configure the ID property of blog. I'm going to drop this thing here, use HILO. Really, nobody knows about this. We haven't really documented it. It actually wasn't even that useful until recently, but now it is. So what this does, HILO, is a sort of a value generation strategy, we call it, for ints. Okay? I'm going to just run it, and I think you'll get the point. So we're now back to ints. This is not GUIDs anymore. I'm running it. And you see something that looks pretty much like the GUID code that we saw a moment ago, right? So there's 2 inserts. They're no longer broken into separate round trips, and we're sending the IDs from the client. How is that possible? How could that possibly work? And the answer is, if I scroll up here just a tiny little bit, I'll find this little gem. So what EF Core does, it sets up a sequence in your database. And when it needs an ID, it will go and fetch a batch of them. It will fetch, I think it's 10 by default, much too low. It should be 100 or whatever. So it's going to fetch, let's say 100, assuming you configure it properly, 100 IDs of blogs, and it's going to cache them client-side. Now, when we want to actually insert blogs at that point, we already have 100 IDs that we know are allocated to us because we allocated them from the sequence, from the database, right? So for the next 100 insertions of blogs, we're basically like GUIDs. We already have IDs, so we don't need to generate them at the database, which means there's no more dependency between the 2 inserts, and we can do them in 1 round trip. So if you're into this kind of thing, and you're doing a lot of related insertions together, and you want to optimize for round trips, this could be a thing for you, like using Hilo or possibly GUIDs, depending on where things go. Yeah, I hope people are still alive. There's still one part, and it's really nice and really easy, actually. Cool. So at this point, we're going to stop with the under-the-hood optimizations. This is a different thing. Everything I've talked about up to now was under the hood. You don't need to know about this. This is the kind of optimization where your code, as it is, has just become faster. It's the best kind of optimization. You don't need to change your code. It's just better by transparently. But now I have to talk about a new API. So who here has already used execute update and execute delete? Good, but not enough. That's exactly why I'm doing this talk. That's exactly the point. So now, let's say we have the following job. I'm going to switch back to inserting 4 blogs. And now, our task is to delete all blogs from the database. Very simple, super simple. So how do we do this in the normal way? You're an EF Core coder. You do this for each blog in context blog. So we iterate over the blogs. Then we mark them as removed. And then we do save changes, basically, right? So just as a reminder, remove doesn't actually do anything. All it does is it marks the blog to be removed in the change tracker. I hope everybody's familiar with the term the change tracker, right? EF Core tracks your changes for tracking queries. There's the change tracker inside. It knows the state of everything. Anyway, if you do EF Core, you already know this. OK, so let's run this code. We're going to stay on EF8 now. There's no more need to look at EF6. This is no more about that kind of optimization. So if you look at this, you will see a bunch of delete statements, one for each blog that we want to delete. They're actually batched, by the way. That's important to note, right? They're inside the same command, so they're in a single round trip. That was not the case in the old EF. Again, old EF did not even batch anything, so it was far worse. I don't know how things worked back then. Anyway, but this does batch, but it's still pretty bad. So it's pretty bad for many reasons. I wonder who here can actually would be able to enumerate all the reasons in which this is bad. So one reason, pretty simple, is we have 4 deletes. If this were 1,000, we would have 1,000 deletes. Each SQL command has an overhead. That's not great. You don't want to do 1,000 deletes to delete 1,000 blocks. There's a better way to do this. But in fact, the real problem is much worse. If you look at the code, you look at this loop that we just wrote here, what this does is it basically downloads the entire table to the client. When you do something like this for each blog in context blogs, then EF Core will transfer all the rows of the table to the client, all of their columns, and start tracking them. Not only does that mean that the entire data comes across the wire, and these rows might be big. Remember, this could have like big columns. Not only that, it's a lot of traffic. It's a lot of network traffic. When EF Core starts tracking something, which happens here, it's a tracking query, it snapshots the data. That means that when it's loaded, it creates a copy, a snapshot of the data. Why does it do that? This is how change tracking works. It creates a snapshot of the data, and then when you do save changes, it's going to compare the current state of the blog instance to the snapshot to know what changed. This is how EF Core detects changes and knows, OK, the rating was modified, but not the name. And then it will send an update specifically for the rating. So EF does change tracking via snapshotting by default. There's other ways to do it, but that's the default way to do it. So not only did we download the entire table, we also duplicated it in memory. OK? Finally, we do save changes. So now we go over and compare each one of these things to their snapshots. That's a whole lot of work. And then we send those 4 deletes, or 1,000. I'll also say we also have 2 round trips here. One to select everything out, and another one to delete. 2 round trips, right? OK, so if you know SQL, you know that this is nonsense. OK, and personally, I think this should have been done like so long ago. It's a bit sad that it took us this long, but I mean, it is what it is. So EF Core 8 has a new API to do exactly this. Yeah, OK, I still have just a tiny bit of time. So I'm going to do this simple command, and that does the exact same thing. If I run this and I look at the actual SQL coming out, then you'll see the right thing, what everybody should expect to see, which is a delete from the table. So this sends a single, short, concise command to tell the database to empty that table. But of course, we'd never want to delete the entire table, right? That's not the point of this demo. The point here is that you can also compose link operators as if this were a query. So I'm going to do where B rating is lower than 2. All the low-rated blogs, I want to remove them from my database. I'm going to write this. And there you see this where, right? I'm going to go even further just to get fancy here, just to prove how cool this can be. I'm going to go into the posts and do any posts p title equals foo. So delete all blogs which have any post, at least one post, whose name is foo. So this is starting to be a pretty fancy query, right? And it works, obviously. You have this translates into a subquery and everything works perfectly. So what we've done here, conceptually, you're using link to express a delete, right? Just like you could use link to express a query. In fact, what link does here is to select or define a set of rows in the database. Then the last operator that you see here, it could be toList, which would mean bring those rows to me, that's query, or it can be update, that same selected set of rows, remove them from the database. I think it's super convincing, it's super elegant to be using link to express this, just like a query. Of course, this begs the question of updates. What about updates? So, of course, we also have this. I'll give a demo. So I'll do a filter because I want to convince you guys that this is real link and so on. And now we do execute update. Of course, update is a tiny bit more complicated because we have to express what to update, right? Delete is simple. It's just delete. So I'm going to do this, setters, and then set the property, and I'm going to say which property I want to change. So let's say I want to change the property. He's getting in the way, all these things. Sorry, the blog name I want to be made bar, for example. I want to rename all the blogs with low ratings. And I'm going to do something even a bit fancier. I want the rating to become the current rating plus 1. Okay? So there's some special stuff here that we designed, that we introduced in EF7 in order to allow you to express the setters on an update command. And if I run this, obviously we'll see what everybody expects to see, which is this thing here. So you can express arbitrarily complex deletes and updates now via link. So in the last 2 minutes that I have, so does that mean that save changes is obsolete? That's kind of the question, right? Like, okay, it's a piece of crap. Like, why would I use it now, right? So that is not the case. That's obviously not the case. You now have 2 ways to perform updates and deletes in EF Core, and they have their strengths and weaknesses. So if you know exactly the kind of delete or update that you need to do, you should absolutely be doing it with execute, delete, and update. That's the first thing that I want to say. Even if you forget performance, by the way, just take a look at this code. Let's do a small comparison here. Let's look at emptying the database in the 2 ways. You've got this old way, and you've got this new way. Which code looks better? Second one, right? I mean, who wants to write something like this with all kinds of steps and a loop when you can just do this? This is the correct way to express it. It's more concise. It's better code, basically. So when you know that you need, for example, let's say you're doing a web service and the client sent you an ID and you're supposed to delete that ID. Of course, you will use the new execute delete because that's the right thing to do. There's no reason to query and then whatever. So that is for sure when you want to do it. Also, when you want to do some operation, update or delete on a set, so it's just for everything where something, obviously you're going to use these things because they're made for it. But there are some scenarios where save changes is much better. So if you want to update a graph you want to do a complex update that touches many parts of a graph, that starts to be very complicated very quickly. There are questions of ordering. Which update should come first, before the delete, after the add, all kinds of things like this. This is where Save Changes really shines. It knows how to do all these calculations for you. I'll give you an example. Sometimes you want to replace something with the same ID. Sometimes you see this. So people will do add and then delete, and then they get a unique constraint violation because the add comes before the delete. It's just a trivial example, right? If you do this with save changes, the order in which you do the operations is meaningless. Save changes actually orders all of your changes internally based on dependencies between them, and it figures out even that you need to do separate round trips for the database-generated IDs. All this complex stuff, basically, save changes does for you, and that is when you should definitely, absolutely use it. It's also worth mentioning, because I'm obsessed with round trips in perf, if you want to do 2 updates to 2 different tables, execute, delete, and update each do their own round trip. So you can't touch 2 tables from a single execute, delete, or update. This is not supported in SQL. You can't do delete this from this table and that from that table in the same delete. Just not supported. So you're going to actually be doing 2 round trips. Whereas save changes can actually do that in a single round trip. It can batch those heterogeneous updates to the database. So there's a thing there that's worth keeping in mind. And the other scenario where save changes is okay, I'm done, pretty much done. The last thing is the very typical scenario which EF had in mind when it was initiated. You have a form, like a WinForms form. You load the blog, you bind it to a form. You don't even know what the user is going to change in terms of which fields on the which properties. So you let EF Core kind of handle it all. It's bound, it's tracked, then you do save changes. EF Core figures out what changed. It's fine, and it's going to just do its job. So save changes has its very good qualities. There's new docs on the website for EF, which tells you a little bit about when you should use each. I'm a bit over time, but I think it's not too bad, hopefully. So there's another slide with documentation, but we're not going to go through this whole technical thing again, and it's not that important. So I hope you enjoyed the talk. I hope you also got some takeaways in general for general perf investigations, like what you should actually concentrate on. And I'd love for anybody to come and talk to me about this stuff in the break or whatever. And now I think it's Q&A. Thank you.
Hey, thank you for a great talk again. And as you are showing the problems with the triggers, why didn't you just add an if into the EF to actually determine that there is a trigger and then fire a second command to...
So there's a very, by design, a very deep principle of EF. We don't go and inspect your database schema in order to determine how we do things in general.
Right.
Never.
You wouldn't explore the schema. You would just try the way as there was no trigger, and then you get an error from the database and say, oh, there's a trigger.
That stuff always sounds good, and it never really works. For example, if you do this kind of thing, the error, and you happen to be in a larger transaction, there's a good chance maybe your transaction is going to get screwed up. I'm not saying there's no way specifically in SQL Server to make this happen, but for example, definitely in Postgres, the moment you have an error, transaction becomes aborted. You cannot continue after an error, and for very good reasons. SQL Server is very tricky around transactions and errors. So you never want to, generally, it doesn't work to code behavior that's going to depend on error data, unfortunately.
Yeah, okay, thank you.
It's not at all stupid, but it unfortunately doesn't work very well.
Thank you so much. Whenever I see like enumerating the iQueryable types, I wonder whether it fetches synchronously or asynchronously.
That's purely a question of whether you're seeing an await or not. So in this case, this is actually synchronous. I didn't want to go into it, but you can do this, await for each. Right? This is it's not new at all.
Enumerable.
So this would make this, and you're right, I should have done this. I was coding live, so I didn't pay attention. You should always absolutely be using, async communication. And EF Core fully 100% supports it. SQL Client, by the way, the driver for SQL Server, has various issues with async, but I'm not going to go into that.
Let me just start saying that this is by far one of the most interesting talks that I've seen in this conference, and also super practical.
Thank you very much.
What I wanted to ask is, when you explained the high-low usage, you mentioned like locking or reserving a number of IDs.
Yes.
How would we go with already existing data for using high-low?
So there's no locking, by the way. Locking is an important word here. All there is just a sequence in the database. So a sequence is a thing that increments. And what we do in EF is we say incremented by 100. That is the only thing that we do. And so now we get 100 new IDs. Now, the assumption here is that there are no existing rows with those IDs. Of course, if somebody has explicitly inserted rows without going through the sequence, things are now screwed up. But that's like bad. That's like a bug, right? So you should always be passing through the sequence and not for like a common technique, by the way, is if you want to insert a specific ID, you use the negative range. You use -1 and -2 because the sequence will never give, it only goes up. But you should never mix both database generated and explicit on the same range. Never.
Okay, thank you very much for the presentation. My question is around the update async, right?
The what, sorry?
The update async, so line 25 to 29. So it's fine that, yeah, we can pass a single value in the where clause, right? But sometimes we have a situation where we would like to reference something in the where in the update.
Yeah.
So for instance, I need to update 5 inventory items, right? Each with different quantities.
Yes.
Is there a plan in the pipeline to support such in EF?
What SQL do you have in mind that would be generated for this?
An update join, for example, in Postgres.
A join.
An update join, yes.
Okay, so what you can do here, this is getting a little bit a bit more complicated, but you can do select B, new, blog equals B, and then, sorry. Basically, you can do a projection before, do your calculation, and then the execute update, the input to your update is going to be that projection. I hope that makes sense, and you can reference anything from that.
So you're saying if we do a projection on line 26 and then we use that in the where,
exactly.
We have it in the set properties.
Exactly. So here, now the B here references an anonymous object that's arbitrary and has been projected out.
Wow, that's brilliant. Thank you.
This actually works very well. We did a lot of testing. There are maybe some edge cases here, because this is pretty complicated under the hood, like to do all the translation, but it does work. So I would be very happy to hear some experiences about it. Like, of course, bugs, obviously. Okay?
Yeah, I have one question to Hilo. I did my implementation of Hilo in the framework 6, so I'm kind of curious. So you use the one sequence for all tables.
Yeah,
right?
That's a mistake in my opinion.
Yeah.
Look, the feature was implemented a very long time ago, and it should be a sequence per table, honestly. But this is now you can, by the way, specify this. So when you do use high-low, I hope I'm not saying nonsense here, but when you configure a specific property, you can also say which sequence it should come from. So you can set it up correctly. The default is not great, and it would be a breaking change to change it for anybody already using high-low.
Yeah, so you will have many holes, but technically you don't care.
With high-low, you always have holes, almost by definition, right? Because you've allocated 100 IDs, and now if the program exits, tough luck, you lost 100 IDs. Is this going to be a problem? Yeah, I don't think so. Usually not. Use big int, first of all, as your IDs, and then you're probably going to be fine.
Hi, really nice examples. Would it be possible to find like a more comprehensive list of these under-the-hood improvements that you guys are doing? Versions?
So there's the what's new that we publish every single release. It's pretty long and big, and it details all of the features and perf optimizations that we do. The one for 8 is not completely done yet, because we just finished 8. But in general, for example, this stuff, if you go to the what's new for 7, you will see this. And there's also a link to a blog post that I wrote about these things as well. But it's difficult to document every little, because there's a lot of little things that we also do that it's too little, let's say. It's too low level there. So we don't always talk about them.
Sure, thanks.
It's hard to document and to talk about these things. It's not a feature exactly, right? It's an optimization, yeah. And I'm not Stephen Toub. I can't write like this huge, I just can't.
I have a question about the execute update. If you have some sort of auditing columns which keep track of who has done the last updates to a row and when they were done, which are often done via the overwriting the save changes method.
Right. Yeah.
If this bypasses the save changes completely, how would you be able to
That's a good
get
question.
these informations in those updates?
That's a very good question. So I'll repeat it. So sometimes people override save changes so that they can introduce extra logic there, like update a column when the row was last updated or various something. So this obviously bypasses that. This is not save changes, and it's a completely different path inside EF Core as well. So it does change it. So it's worth saying that even before, when you did this kind of thing, if anybody uses SQL to directly update the table, it would also bypass that save changes as well, right? So the problem is a bit more general. And if you're going in this direction, my advice would be to think about maybe looking into triggers to do this. So you would be doing that update on the database side, but then you get into trouble with the other optimization. So, I mean, I'm sorry. I mean, you know, we're just the client data for, you know, for SQL Server in this case. If you use Postgres, you wouldn't have that specific problem, but it's a very good question. What is worth understanding, execute update is basically a much lower level API compared to save changes, right? It really is a way to directly model an update statement in SQL. So whereas save changes is something completely different. It's a very high level thing and so on. So I don't have a super good answer for you, unfortunately. Yeah. You could wrap execute update and make sure that to change its own actual expression tree so that it also does the same update if you want. That's a bit complicated, and you would have to go through that wrapped API instead.
Okay, thanks.
I would love to have a better answer, but I don't.
I think we have time for one last question.
So you've mentioned that the SQL merge statement is often misused for upserts.
Yeah.
So my question is, why is that a misuse? Because in our case, when we try to upsert a high volume of data and we use SQL merge in combination with temporary tables and SQL bulk copy is the most performant option of all. So why is that?
I was being a tiny bit facetious. So it depends exactly what you do there. So typically, if you're bulk importing into a temporary table and then using merge, it can work very well. But the really important thing to understand is that merge is not atomic. The thing I said before, if you're expressing an upsert or insert or update via merge, merge has two legs, right? You give it two legs. Those two legs are not guaranteed to be atomic. So it's possible that it's going to check for the existence of the row. It's going to see, oh, there's no row there, so I'm going to insert it. And in the meantime, that row exists. And when it tries to insert, you get a unique constraint violation. In that sense, it was not. People think that it's going to be atomic, but it's not. So I don't know if you've had this, but if you have high concurrency and you're using merge in this way, if you have high concurrency, then it's not going to be atomic, and you might get errors. And the problem here is that SQL Server doesn't have a native upsert command like most other databases, so people have to use merge, which is not really made for this originally. That's my answer to you. So it will work fine as long as there's no concurrency, but I mean, yeah.
Yeah, we just lock the table.
That's fine. Yeah, I mean, that's a solution, but that's not the way it should be, right? You should be able to do upsert without locking the entire table. That's my opinion anyway.
All right, thank you.
My pleasure. So I guess that's it, right? Sure. So again, if anybody has any further questions or wants to take a look at the code or anything, just I'm going to hang out here for a bit, and then I'll be outside as well. So I'd love to talk to you.